I think the message will pop up when you're live.
Yes, it is. Okay, I think we're live.
Yes, go ahead. Introduce yourself, please.
All right, so hello everyone. I would like to first start by thanking everyone that is with us in the Zoom call and also everyone that is present physically in person. So right now I'm going to be presenting to you guys this presentation that I've been working on. It's about my project with Eartech Information Technology. This was part of a summer internship that I had at this company. As you can see here, this was the workshop that inspired me to do my project, which was a workshop about the robotic arms conducted by Tulip Technologies, based here in Turkey. So I would like to first start with a quote that we will get back to later. It is by Mark Kennedy, and he said, "All of the biggest technological inventions created by man, either the airplane, the automobile, and the computer, says a little about his intelligence, but it speaks volumes about his laziness." As we can all agree, we all create inventions that should serve us and serve humanity, which also speaks about our laziness. So for our agenda today, we will start with a small introduction, and then we will proceed to the understanding of robotic arms in general, then the power of hand gestures, multiple fields of the application of these hand gesture controlled robotic arms, and then the challenges and constraints that face these robotic arms. And then we will proceed to future developments. And I'm going to talk a little bit about my own project and what I took from what's already existing and how I tried to make it into my own thing. And then we're going to finish up with a small conclusion. And there is a little bit of a surprise at the end. It's a bonus simulation using SolidWorks. So we'll basically get to play a little bit with a robotic arm. So, revolutionizing robotics, exploring the potential of a hand gestured controlled robotic arm. We all know about the robotic arms. We're going to start up with a introduction. Welcome to this world of hand gesture controlled robotic arms. In this presentation, we will explore the potential of this revolutionary technology that allows humans to interact with robots using simple hand gestures. Join us on this exciting journey. So the basic knowledge that we have to know about robotic arms, as we can see from the picture, they have multiple joints that mimic the joints present in the human arm, which are the shoulder, elbow, and wrist. And usually in the robotic arms, they take the form of motors that move certain links in order to accomplish a task. So the robotic arms are mechanical devices designed to imitate human arm movement. They are widely used in the industries like manufacturing, healthcare, and space exploration. We will talk about these more detailed in the upcoming slides. With recent advancements, hand gesture control has emerged as a promising way to enhance the usability and flexibility of a robotic arm. What's better than to program a robotic arm to make a task happen is basically to have it follow a certain movement that is very organic, which is the movement of the hand or the human arm. And that's what we want to do. Now, the power of a hand gesture, since we want to mimic it, we have to understand the power behind it. So the hand gestures are natural and intuitive form of communication. By leveraging computer vision and machine learning, robotic arms can interpret hand gestures to perform various tasks. This technology opens up a whole new realm of possibilities for a human-robot interaction. So what we mean by this is, since we have the computer vision, which we can interpret using either cameras or similar sensors, and then couple it with machine learning that would allow us to identify the hand in the picture and then follow its movement and then feed that input data to the robotic arm, that would allow the robotic arm to move accordingly. In my personal project, I did not use any cameras to have this data, but I used something else. I would say that is less complicated in my opinion, and just in order to simplify it and try to build this sort of low budget hand gesture controlled robotic arm. So for the applications of this new technology, in the healthcare field, the hand gesture controlled robotic arms have immense potential in the healthcare industry. As we all know, surgeons can perform delicate operations with precision, reducing the risks of human error. Additionally, these arms can assist patients with limited mobility in their daily activities, providing them with more independence. As we know in the medical field, precision is very crucial, and the human error sometimes is the main differentiator between life and death. So if we can minimize this human error as much as we can, we should take the decisions to make it happen. So for the robotic arms, they could provide stability. They could eliminate the shaken errors and resulting in a safer and better ratio. So for the manufacturing field, in manufacturing, the hand gesture controlled robotic arms can streamline the production processes, enhance the worker safety, and increase the efficiency. Workers can manipulate the robotic arm from a safe distance, reducing the risk of accidents and repetitive strain injuries. These technologies can also enable quick reprogramming for different tasks. This part, we have talked about it immensely with Tulip Technologies, as they showed us different robotic arms and their use in this industry. We have talked about the workers being exposed to certain danger when they come to repetitive tasks. They might have repetitive strain injuries, and also if they have to carry loads, that could also injure them. So if we can substitute the human by the machine, in this case, we would provide a more safe environment for the workers to be in. And for the last field that we're going to talk about is exploring space with gestures. As we all know, we are in a race to space. Everyone wants to go outside the Earth, so we are all working to try to discover the outer space, from going to Mars, from dropping the rover on Mars, from exploring the moon further. So this space exploration also involves the remote operations, whereas astronauts cannot directly manipulate objects. The hand gestures controlled robotic arms can bridge this gap by allowing astronauts to control the robotic arms on the spacecraft or rovers using the intuitive hand gestures. This technology opens up new possibilities for space missions. Like any technology, these hand gesture controlled robotic arms have challenges and limitations. So while the hand gesture controlled robotic arms offer exciting possibilities, there are challenges to overcome. Ambient lighting, for example, conditions, for example, or occlusion and variation in the hand gestures can affect the accuracy. Additionally, training the system to recognize a wide range of gestures require extensive data collection and robust algorithms. So we need a huge computational power. This was one of the main concerns if we want to, like, with working the algorithms and for the machine learning, it requires a lot of computational force. So we're gonna see what Google did about this later. So hold on. Now for the future developments, the future of the hand gesture controlled robotic arms looks promising. Advancements in artificial intelligence and machine learning algorithms will enhance gestures gesture recognition accuracy. Miniaturization of the sensors and improved computational power will make these systems more compact and affordable, opening doors to a widespread adoption. As we can see, as of 5 days ago, Google announced that their new quantum computer, they have finally achieved it, and they have announced that it can complete 47 years of computing tasks in 6 seconds, which is crazy. It is 241 million times faster than Google's 2019 version. This has been posted on LinkedIn, so we can see that the potential here is limitless, especially when it comes to data analysis. So we can make we can collect all the data and all the processes, and we can just solve everything just in an instant, which is going to make the hand gesture recognition and everything much faster and much on point and accurate. Now for the fun part, my project. So remember when we said that quote by Mark Kennedy? Speaking of laziness, I thought about making a hand gesture controlled robotic arm that is compatible for desktop, which means that it has to be small, compact, and a lot of safety regards. It's going to be close to the user. It's going to be close to his belongings. And since laptops and everything are quite expensive, we don't want to damage any of that. So all of those things are taken into consideration in the making of this project. This is the model that we are going to be toying with later. And as for now, I'm going to show you what the end result would look like, and it will be 3D printed and then assembled. So this is what it's going to look like. We basically have a turntable here that has a main servo motor. We have a lot of other servo motors on the sides. This one has 3 main links, and this is the gripper. So this is the arm, turntable, and the gripper. So the hand gesture controlled robotic arm project aims to create a desktop compatible robotic arm that can be controlled using hand gestures. The robotic arm will be 3D printed, then assembled, with its movement driven by servo motors, which are the dark gray boxes with wires coming out of them. And it's going to be controlled by Arduino Uno, receiving information through a Bluetooth receiver. The control signals will be captured from a hand exoskeleton, which resembles a glove that usually envelops your hand. And it's going to have Arduino Uno, an accelerometer, and a flex meter for the finger for the gripper. And of course, a Bluetooth emitter, so it can communicate the information. So as I spoke about, instead of having computer vision, so instead of having like a camera and then I'm going to have to process the information taken by the camera and identifying the hand and then its movements, I would instead capture the movement using an accelerometer. So if, like, for instance, I move my hand to the right side, the robotic arm will turn towards the right side. I mean, if I program it to do so. If I put pressure on the flex meter that is going to be going throughout the finger, then that's going to send the signal that I am trying to grip, which is going to cause the gripper to close. So now for the parts, this is the arm, and in blue we have all the components that are the parts of the sub-assembly. We can see also some bearings. These bearings, for example, are not here as they are usually just bought from, and they have standard sizes. So this is the arm. It has 3 links, as we spoke about. The second one is the gripper. It looks quite complex in the geometry, but the working principle is quite easy. As we can see here, we have this gear right here. It turns this outside part to close it, and then this inside part. So as the gear turns, it's going to hit this gripper from the outside and this gripper from the inside, causing it to go in the reverse directions. So it's either going to close or it's going to open. And all the other pieces are used just to mount and clamp these together. This is for the turntable. And for the turntable, we have a motor inside it that is going to turn the base, and it's going to work as the shoulder of the robotic arm. And this is the exoskeleton. In the middle, there are some sketches that I worked on. In the upper right side, we can see the exoskeleton, what it's gonna look like. So it envelops from the wrist and it goes all the way down to the fingertips, right? And the flex meter is a string. I'm gonna show you how it looks later, the flex meters. And they would go with the finger. So whenever you flex your fingers, it's gonna send signals to the Arduino Nano chip, and then it's gonna send the signal to the Bluetooth emitter, which is gonna send the signal to the robot, telling him that, oh, the gripper should close. And that's basically the working principle, as well as the accelerometer. Accelerometer can see if I'm moving my hand left, right, up, down, and same thing, it's gonna emit information. And that's basically the main information flow. I'm just gonna go over this really quick. This is the right here. Oh, my bad. So this right here is the coupling of the main servo motor that is in the turntable. These are the 6 servo motors that are in the robotic arm. And together they are usually coupled like this with a battery here. This string right here, it looks like a string with a lot of squares. This one is a flex meter. So the first one is just to test it. Here we attach it to also, we attach the breadboard to a blue chip. And this blue chip helps us to measure the acceleration, velocity, orientation, displacement, and many other motions related parameters of a system or an object. And it's also what's gonna send the information to the nano, send it to the Bluetooth, and then send it to the robot. And yeah, and here, of course, we're gonna have a lot of flex meters, so we can know exactly like the amount of force that we're gonna use and everything. So this is a assembly of like multiple flex meters together. How are they supposed to be coupled? Now for the conclusion, the hand gesture controlled robotic arm have amazing potential, and they have the potential to revolutionize various industries and improve human-robot interaction. With advancements in technology, we can expect more precise and intuitive control, leading to a safer and more efficient operation. Embrace the future of robotics and explore the endless possibilities. Now, before we jump into the Q&A, I would like to show you guys a little something. Okay. Can you guys see the robotic arm?
Yes, we can see.
Yes, all right. So as you can see, this robotic arm is made of many pieces. These are the main parts. So we have the base, right? And then we have, this is the equivalent to the turntable. Then we have the first link, sorry, my bad. This is the turntable. This is the first link. This is the second link. And then we have the third link, which is comparted from all of these, right? Like together. And then we have the gripper, which are those two right here. So as we can see, we have, so if I make these float, I can move them to whatever I want, right? They can just move like this. And with the mates, I can also like tell them exactly how to move and where to move. Same for this. If I can just make it float for this configuration, now I can see that I can also turn it, right? So like, let's say if I want to grip something and I can't go like this, I would want to flip it a little bit and then grip it, right? So that's the reason behind this one turning as well. Same thing with this one. I can make it go up and down, right? Giving me a full 360 motion, right? And then we have this one as well. I can also make it float. And this one turns in the other direction, right? So I can turn and then go inwards. So I can turn like this, fix this again, and then I can turn again here for this motion. Now let's see what happens if I can move this one right here. Then the whole thing is gonna move, right? And then same here again. If I move this one, if I move this link, right? If I move this link, which means I'm gonna have a motor right here, turning the whole table, right? It's gonna turn all the links together, right? So if let's say I want to grab something here, I would go all the way down and then grab it and then go back. And then at the end, also here, if I have, let's say, the servo motor on this table is turning, it's going to cause everything to turn, right? And then that is basically it. So this is a small presentation about the working principle of the robotic arm. And with that, I will leave you guys. And thank you so much for your attention. And I'm done. Now back to the Q&A. Any questions? If we can get some questions from either people on Zoom or that are attending physically.
I have a small question.
Yes, Amar.
Could these robotic arms maybe get hacked? Are they like hackable or something?